At 6 in the morning in Guangdong province, a 60-year-old farmer named Tang Zhengqing is already walking through the rain with a bamboo stick. 7 ducks waddle ahead of him along a muddy path, crossing bridges and streams on a 20-minute march to the rice paddies. They have done this every morning for 3 years. When they arrive at the flooded fields, the ducks launch into the shallow water and begin feeding immediately. Their flat bills sift through the mud, snapping up golden apple snails that would otherwise shred young rice seedlings down to stumps. Between the rows of bright green stalks, they tear out weeds by the root, swallowing seeds that would have sprouted into crop-choking ground cover within days. Their constant paddling churns the water, pulling oxygen down into the soil. And everywhere they go, they leave behind droppings rich in nitrogen, phosphorus, and potassium, nutrients that seep directly into the root systems of the rice plants surrounding them. Nobody told these ducks what to eat. Nobody trained them to avoid the rice. They simply do what ducks do in shallow water, and what they do happens to solve nearly every problem that modern chemical agriculture was invented to address. That is not a poetic exaggeration. Peer-reviewed field research has measured the pest control effectiveness of ducks against rice plant hoppers at over 98%. Against rice leafhoppers, the number is 100%. These are results that chemical pesticides struggle to match, and the ducks achieve them without contaminating a single drop of groundwater. This is the story of a farming method that Chinese farmers perfected 600 years ago, then abandoned for industrial chemicals that promised faster results. But those chemicals poisoned the soil, contaminated the rivers, and sickened the farmers themselves. And now, an entire country is racing to bring the ducks back before the damage becomes permanent. To understand why thousands of ducks are waddling through rice paddies across China, you first have to understand what chemical farming did to the fields they are waddling through. And the damage runs deeper than the soil. China feeds roughly 20% of the world's population, using about 7% of the world's arable land. That math has always demanded intensity. Starting in the mid-20th century, Chinese agriculture industrialized rapidly. Synthetic nitrogen fertilizers promised bigger harvests. Chemical pesticides promised freedom from the insects and weeds that had plagued rice farmers for millennia. Farmers adopted both at an enormous scale. The results were immediate. Yields climbed, insects died, weeds vanished. For a generation, the chemicals seemed to work exactly as advertised. Then the bills started arriving. More than 150 million acres of China's farmland are now classified as contaminated. Chemical residues have leached into soil, rivers, and groundwater systems across entire provinces. Major waterways, including the Yangtze and the Yellow River, have tested positive for organophosphorus and carbamate contamination. Government estimates place the number of annual pesticide-related poisoning incidents at over 200,000. The insects adapted. Pest populations that had been suppressed by chemicals evolved resistance, requiring stronger doses, which required even stronger doses the following season. Farmers found themselves trapped in an escalation cycle, where the chemicals grew more expensive every year and less effective every season. One rice grower near Tang's village in Shenyang lost 2/3 of his entire harvest to insects in 2013. Despite spraying heavily with chemical pesticides throughout the growing season, the soil itself was dying. Decades of synthetic fertilizer had stripped the microbial life that makes soil fertile in the first place. Fields that once produced healthy crops with compost and natural inputs now required increasing volumes of purchased chemicals just to maintain baseline productivity. The degree of over-fertilization in Chinese rice crops has been measured at over 43%, meaning nearly half the chemicals applied were running off into waterways or locking into the soil as contamination. This is the landscape the ducks walked into. Fields that had been chemically managed for decades, soil that had lost much of its natural fertility, ecosystems so degraded that Tang had not seen an egret in his village for over 10 years. The method those ducks are performing is called integrated rice duck farming. It was first documented in China roughly 600 years ago during a period when farmers developed sophisticated symbiotic systems for growing rice alongside fish, ducks, and aquatic plants in the same flooded paddies. Ducks ate the pests. Their droppings fed the soil. Their movement through the water aerated the root zone and physically strengthened the rice stalks. Farmers harvested rice and protein from the same piece of land in the same growing season. For centuries, this worked. Tang himself remembers how it functioned in his own village. Back in the 1970s, before chemical pesticides and synthetic fertilizers arrived, his family enriched the soil with compost, made pest deterrents from herbs, and relied on ducks to control snails. Insect attacks, he recalled, were barely a concern. Then the chemicals came, and the ducks disappeared from the paddies almost overnight. Why spend months managing a flock when a bag of powder could do the job in an afternoon? The logic was irresistible. An entire agricultural tradition collapsed in a single generation. What replaced it was faster, cheaper, and ultimately catastrophic. And what is replacing it now looks almost identical to what came before. The modern revival of rice duck farming did not begin in China. It began on a small farm in Fukuoka Prefecture, Japan, in the late 1980s. A farmer named Takao Furuno had been practicing organic methods for a decade when he discovered the traditional AI-GAMO technique. His first experiment worked, though not without problems. The ducks ate things they should not have. Predatory birds picked off his flock. The timing was difficult to calibrate. Furuno spent years refining the system. He identified that ducklings should enter the paddies at 7 days old, at a density of 15 to 30 birds per tenth of a hectare, and should be removed after 8 weeks before they grow large enough to eat the rice. He added loaches, a small freshwater fish, and a zala, a nitrogen-fixing aquatic fern, to create a complete integrated ecosystem in a single flooded field. By 1989, he had engineered the method into something replicable. His crop yields without any chemicals matched or surpassed those of farmers still using conventional methods. His 3.2 hectare farm eventually produced rice, organic vegetables, eggs, duck meat, and fish, generating an annual income equivalent to $160,000. Furuno published a book called The Power of Duck. The method spread across 12 countries. Over 75,000 farmers in Japan, South Korea, China, Vietnam, the Philippines, Bangladesh, Iran, and Cuba adopted some version of it. In the Camargue marshlands of southern France, a farmer named Bernard de Pujol became the only rice grower in Europe using ducks instead of chemicals, after adapting Furuno's techniques to Mediterranean conditions. What makes the duck system effective is not one behavior. It is the simultaneous performance of 4 distinct ecological functions, operating continuously across the same field. The first is pest predation. Ducks consume golden apple snails, one of the most destructive invasive species in global rice farming. They eat plant hopper nymphs, leaf hopper adults, and insect larvae that bore into rice stems. Research has shown their effectiveness against plant hoppers exceeds 98%. Unlike broad-spectrum chemical pesticides, which kill beneficial insects alongside pests, ducks selectively target the species that damage rice, while leaving predatory insects and spiders largely undisturbed. The second is weed control. Ducks eat weeds, weed seeds, and aquatic plants that compete with rice for light and nutrients. 4-year field studies measured cumulative weed density reductions of over 99% in rice duck systems. A grazing density of 225 to 300 ducks per hectare matched or exceeded the weed suppression of chemical herbicides. The third is fertilization. Duck manure distributes nitrogen, phosphorus, and potassium directly into the paddy water, where it becomes immediately available to rice root systems. Over time, this organic input increases soil microbial activity, improves water retention, and builds the kind of long-term fertility that synthetic fertilizers actively degrade. The fourth is physical disturbance. The constant swimming and dabbling of ducks aerates the water column, increases dissolved oxygen, and physically agitates rice stalks in a way that stimulates stronger stem development. Farmers consistently report that duck-raised rice produces sturdier plants more resistant to typhoons. The movement also helps prevent harmful algae blooms and reduces methane emissions from the standing water, which is significant because rice paddies are one of the largest agricultural sources of methane globally. These 4 functions, running simultaneously across a flooded field, replicate with remarkable precision what industrial agriculture tried to achieve with 4 separate purchased inputs: pesticide, herbicide, fertilizer, and mechanical tillage. The ducks do all of it. They do it continuously. At the end of the season, the farmer sells them for meat, generating additional income from the very tool that replaced the chemicals. The results show up not just in data, but in the landscape. After Tang reduced pesticide use, egrets returned to his village for the first time in a decade. Pheasants appeared in his rice fields. The silence that had settled over chemically managed farmland began to lift. This sounds like a clean victory. In some fields, it is. Rice duck systems increase productivity between 10 and 20% over conventional chemical farming, while reducing input costs, eliminating pesticide exposure, and producing premium organic rice that commands higher prices in China's middle-class market. But the method has not replaced chemical farming at any meaningful scale, and the reasons are not sentimental. They are structural. Rice duck farming requires labor. Someone has to hatch the ducklings, manage the flock, maintain fencing against predators, calibrate water levels so the ducks can swim but still reach the bottom, and remove the birds before they start eating the crop they were hired to protect. In a country where rural labor has been migrating to cities for decades, that is not a trivial problem. Scale is another constraint. The method works beautifully on small holdings. Furuno's farm is 3.2 hectares. Tang's is similarly modest. Applying it to the vast industrial operations that produce the bulk of China's grain would require entirely different infrastructure, and there is a harder truth underneath both of those practical problems. Chemical farming is easier. Spraying a field takes hours. Managing a living ecosystem takes months of daily attention. The entire structure of modern agricultural economics was built around the assumption that farming would get simpler, faster, and less dependent on human judgment. Rice duck farming asks farmers to reverse that trajectory entirely. Neither the optimism nor the skepticism tells the whole story. The method works. The scale challenge is real. Both things are true at the same time. What is happening in these paddies, though, is larger than a farming technique. It is a confrontation with the question that industrial agriculture has spent 70 years avoiding. What if the solution to the damage caused by replacing natural systems with chemicals is not better chemicals, but putting the natural systems back? The ducks did not need a research grant or a chemical patent. They needed shallow water, young rice plants, and the freedom to do what 600 years of coexistence had already proven they could do. And when they were given that chance, the snails disappeared, the weeds died back, the soil recovered, and the birds returned. Tang still walks his ducks to the paddies every morning. Rain or dry season, the routine has not changed. The bamboo stick guides them along the muddy path. The ducks already know where they are going, and the fields they walk into look nothing like the chemically saturated ground they inherited. They look, for the first time in decades, like something alive. Ducks are not the only ancient solution being revived to fix the damage caused by modern farming. In our next video, we look at what happened when one country stopped fighting its rivers and started letting them flood on purpose.